So the most basic idea of solving similar triangles is that when triangles are similar, and you're told ahead of time, so I'm telling you these are similar, we know that we can match sides that go together. So again, our positioning matters. 10 is to the left of this angle, and it's going to match with 8 because it's to the left of that angle. We can't match big with little necessarily. We could measure the sides. This 10 is the longer side, 8 is the longer side. But sometimes we can't tell for sure. We can use the angles positioning to help us. Or we can use a similarity statement to match the pieces. So in this case, they're lined up the same way. 10 is going to go with 8, and 4 goes with x. We know this because, again, the sides must grow and shrink by the same amount. So the amount this one grew, this one has to grow by the same amount. After we set it up, we cross multiply. 10 times x and 4 times 8. And we finish our algebra solving. So x is going to be 3.2, or 32 over 10, or 16 over 5. So the basic idea is that similar shapes will grow and shrink by the same amount. Let's try another one. And I'm sorry I'm not able to draw as easily with this digital pen. My triangle lines are very crooked. So I've been going left to right, and you may ask, can I go right to left, and you can. So go ahead and pause it and try. How would you solve this? If we're being careful, this is our hypotenuse, and this is our hypotenuse. They're across from the 90. So they go together. Then this is the bottom, and this is the bottom. They go together. I said I was going to do it the other way, so let me set it up again. So I went right to left, right to left. It is also okay to go right to, I went left, right, left, right. It's also okay to go right to left. 4 goes with the hypotenuse 120. But you have to go back to this one. 3 goes with x. Both of these, when we cross multiply, 4 times x and 4 times x, we'll end up with the same answer. 4x equals 360. 4x equals 360. And we divide by 4. We get 90. So if we can match sides, then triangles are similar, and we can set up a proportion and cross multiply. So these are matching the actual pieces of the triangle. The bottom with the bottom, hypotenuse matches with hypotenuse. Then we learned a specific triangle that has to be right. And what people had found is if you take a right triangle, here's the right angle, if you go and get the altitude, which is from the very top of the right angle all the way down perpendicular to the other side, we have actually 3 similar triangles. So if I take out this triangle on the left, I'll color it blue, and draw it by itself, it would look like this. The small leg is A, the long leg is X. Then if I take this other triangle and rotate it, and I'm coloring it yellow, if I rotate it this way and face it so it's facing the same way, you're going to have the short leg on this one is X, but the long leg is C. So because these are similar by angle, we could see this short leg will match with short leg. This longer leg will match with this longer leg. In doing that match, you will get A goes with X here, the smaller leg, and then X will match with the longer leg. And we see this is referred to as the geometric mean. It's going to give you a form of average. It's really like turning things into a square and finding the square root, so we know how much each side is. But instead of redrawing and pulling these out the way we did, we just learned a pattern. A over the middle one, the altitude, equals the altitude again over the other side. A over X equals X over C. So let's see how that would look in a real problem. 8 over X will equal X over, I was going to put 4, let's do 10. 8 goes with the middle one, as the middle one goes with 10. But don't be fooled and always put X twice. A lot of students see that X shows up twice because it's possible that the number will come up twice. We'll look at that in a moment. So if I cross multiply, I get X squared, and then I get 8 times 10. It's 80. The last step is to do the inverse or opposite of X squared is square root. And a whole other lesson, if you're not familiar, is how to reduce a square root. We factor it. 8 times 10, which is 2 times 5, and 2 times 4, which is 2 times 2. So the factors of 80 are 2 times 2 times 2 times 2 times 5. We've learned to circle the pairs, take them out because we're referring to one side of a square. So for every 2, we pull one out. And we get 2 times 2 radical 5, or 4 radical 5. But again, this only works when it's a right triangle and has an altitude. So you have to be able to recognize that triangle shape. If we forget the formula, we could separate them and match sides. So let's look at one more, and then I'll give you the harder version. Maybe the number here is oops, put an X. So the number is in the altitude rather than a variable in this spot here. Again, this side divided by the altitude equals the altitude again divided by the other side. And we'll get this time 6x equals 100, and we'll divide by 6. So notice that the x doesn't repeat unless the x is in the middle here. So a more challenging problem would be something we did see on a few worksheets. When they give you something like this, and up here is the variable. So you cannot use the pattern. So again, we can make similar triangles and compare sides. That's possible. We would use this big triangle, and we would use the medium triangle. So we could rotate them and make them match the pieces. But the other way we could do this is just add another letter here and do the pattern. 6 over y equals y over 8. Y squared equals 48. Square root it. Again, we factor 12 times 4, or 2 times 24, 2 times 12, 2 times 6, and then 2 times 3. So the factors of 48 are 2 times 2 times 2 times 2 times 3. We take out a pair of 2's, and we get 4 radical 3. So if I do that, I now have 4 radical 3 here in this triangle. I have 8 here, and I have x here. I could use the Pythagorean theorem. So it is still possible, if you're looking for an outside piece and not the middle one, we can still use the middle one, use the pattern we learned, find the middle one, and then use the Pythagorean theorem. So that is the pattern we use with right triangles. There are 3 other patterns. We learned when there's an angle bisector, which would show the angles here being cut in half. We learned when there's a triangle with parallel lines. By angle, angle, they end up similar. And the third one is just a variation or a version of the third one. It's when we have 3 parallel lines, and it's aiming towards a triangle but doesn't finish. All 3 of these have the same pattern for setting up the sides. Now, this particular first one is the sides and the bottom. A over B will always match the proportions of the other side, the right side over the bottom, equals C over D. So again, this one over this one will equal this one over this one. That same pattern is going to work for the second version. A over B equals C over D. And again here, the proportions of this piece and the one below it will always equal the same growth or shrinking proportions of the right side divided by the other piece on the right side. So we've used these many times. We'll go over a few. But before we do that, let me show you something important about this middle one, where every now and then they'll throw in a problem to try to trick you. Notice on this particular formula pattern, we have no bottom pieces of the triangle. So don't be tricked when you see that. Let me show you how you're sometimes tricked. So watch out. If you have a triangle like this, and the lines are parallel, you might have x and 4, and 30 and 50. Some students are tempted to set this up. X over 4 equals 30 over 50. Why won't that work? It won't work. Well, remember the pattern we just finished looking at. What it really looked like was A over B, x over 4, equals the other side, C over D. And we don't have those sides. So that pattern only works with the sides. If we're not given the sides, we need to just look at these as if they're any other type of similar triangle. We have to separate them. So the x is here and the 30 is here. Now we get the whole big one. 50 is on the bottom, but how much is this piece, right? It's not 4. So that's why if we put x over 4, we're only looking at this piece, not the whole triangle. But 30 represents the whole piece. 50 represents the whole piece of this triangle. X represents this piece. So we need to represent the whole side to match with it. This needs to match with X. Not just a piece of it. Not just the 4, which is from here to here, a little small portion of it. So we actually would have to add these together. X plus 4. Now we could match them. X goes with x plus 4. 30 goes with 50. Let me show you it again in another example. some would say 4 over 8 equals x over 80. And again, that only works if we have these numbers here and here. This side over this side equals this side over that side. That is the pattern. When it comes to the bottom now, we're talking about similarity in a whole triangle. So whenever we see that bottom piece, we can't use that pattern. We're going to have to separate the triangles. 4 goes with 4 and x, or the small triangle. 80 is in the bottom of the big triangle, and we got to consider, what is this whole side? Well, it's not 8. That's why 4 over 8 won't work. The whole side is 8 plus 12, which is, 8 plus 4, which is 12. So now we can match it. 4 goes with 12, x goes with 80. And we can cross multiply. So 12x equals 320, and then we divide both sides by 12. But let's look at the times the pattern does work. That was just a warning to watch out for. Here's one of the ways we would set this one up. X goes with 12, 3 goes with 10. We're dealing with this side and this side, this side and this side. And then we cross multiply. How would you set this one up? And you could do 80 over 64 equals x over 12. You can do the start on the left or start on the right. X over 12, this over this, equals this over this. And really, if we're honest, we could do bottom, top, bottom, top. We could honestly do 64 over 80 equals 12 over x. But you don't want to get too involved in all the different combinations. So then again, we then cross multiply and solve. How would you set this one up? And so again, 82 goes with x. 49 goes with 32. We often do this and just set them equal. When we cross multiply, we get 49x and 32 times 82. So if you set it up slightly differently, maybe you went right, left, just make sure the 49 and the x go together when you cross multiply. How about this one? So if we rotated it, right, it would look like this. X and 22, 84 and 30. Technically, that would be the way we learned the pattern. X goes with 22, 84 goes with 30. So 30x equals 22 times 84. However, we also learned that you can go up, down, up, down. 84 over x equals 30 over 22. It will still work. And when we cross multiply, again, the 30 ends up with the x. So it ends up with the same answer. So I'm not continuing to solve it, just seeing if you can set it up correctly. We're assuming you can get x alone. So let's try one last one. How would you set this up? Pause it, try it. Did you put 12 over x equals 33 over 44? Because if you did, You are wrong. Did I trick you? So this was the type that we just finished looking at a few practice problems ago. This was the one that is not following the pattern we learned. The C and the D are not there. It's got the bottom being used. So in fact, we have to separate the triangles. 12 and 33 are the small triangle. 44 is on the bottom of the big triangle. And x plus 12. X is just a piece of the big triangle. We really need the whole left side, x plus 12. So 12 goes with x plus 12. 33 goes with 44. I want to make this a little easier to cross multiply. I'm going to reduce it. 3 times 11, 4 times 11. So the 11s cancel. That will make it slightly easier to cross multiply without a calculator. 3 is going to multiply to x plus 12. Don't forget, it will multiply to both, not just one. And the 4 and the 12 will multiply. So I have to distribute here. And then get x alone. Subtract 36. 3x equals 12. Divide by 3, x equals 4. So those are the patterns we learned for similarity. We learned how to test for similarity. We learned how we can match the sides of similar shapes and set up a problem to cross multiply. We learned the 3 patterns we just looked at. And then here are the 3 patterns. No, is that it? There they are. We learned the 3 patterns, and we also learned the one with a right triangle. X goes with A, as A goes with Y. Similar shapes grow and shrink with the same scale factor. Again, the angles are always congruent. They have to be exactly the same. The sides, however, are not the same. They're not exactly the same. They're going to grow and shrink by the same amount. When things grow and shrink by the same amount, we call that proportional. They have the same scale factor. And so that's why even in the 30, 60, 90 triangles, all 30, 60, 90 are similar. So we learned in the 30, 60, 90 ratio, let me make it look a little more accurate. We learned that the small side's 1, the hypotenuse is 2, and the long side is radical 3. So we can actually find any 30, 60, 90 by matching the sides because they're similar. So it works the same way. 1 goes with 10 radical 2. And the longer side, radical 3, goes with x. When I cross multiply, I get 10 radical 2 times radical 3 and 1 times x. And we know we could multiply radicals and radicals together. So the answer is 10 radical 6. This is actually leading into sine, cosine, and tangent. And each of the degrees we learn in the next chapter are going to be based off of similar triangles, which is why our calculators are programmed with certain proportions. So hopefully this was a little bit of a review. If you were absent, you were ill, if you needed to brush up before the test, but hopefully the basic ideas make a little bit more sense.